All right. All right, guys, so just let you know, I'm doing okay. How are you doing? Okay. Thank you so much. It does make for a better class when the teachers are here. Next week is going to be a week of quizzes. Oh, yes. So in each section of the lab, there's going to be 2 quizzes next week. So a quiz on chapter 1, and then a quiz on the solvent equations we're going to get into today. And the first part of the solvent equation should really be a review. But I am going to kind of build up as if you haven't really done much of it before, just in case it's been a while, or that might be a true statement. I don't know. So in general, of course, homework questions I'm really going to take in the lab, but are there any general questions about the class or any concerns or anything? Yes?
I think we actually going to need like the book.
To be honest, you never need a physical copy of the book. If you just want the ebook on the MyMathLab, like I said though, next semester.
In the class?
Huh?
Book in the class? Like you can bring my computer in here.
It would be kind of mean if I said you don't need the book, but on Tuesday you better bring the book. That would be evil. So in the classroom, if I need to show you something from the book, I'll just plop up the ebook on the overhead.
Okay.
Yes?
You always want us to have the lecture notes.
Yes, the blue book you need to bring. So hopefully you've got that, you brought it. If you didn't, I'm going to splash some of that up on the overhead. Blue book, yes. This guy that I've mentioned a couple times. The bookstore? Yep. So if you do not have that blue book yet, we're going to start working out of it, but you can follow along pretty easily. I'm going to ask you to do some problems, but I'll try to put those problems on the overhead if you don't have it. Or you can sign up next to somebody that does have the blue book. You look for those people. They look like they're going to be mean, maybe find somebody else. So guys, and also what's in our future, we're going to start with solving equations, but what's going to be coming right after that is everybody's favorite thing. What's your favorite thing analogy? I'm being sarcastic. Word problems. Normally graphing is like right up there with word problems. We're a poor little word problems. I get such a bad rap. But obviously, the problem with word problems the hardest part should be setting the equation up. Solving the equation should be the easy part. Right? And of course, setting the equation up is going to be the hard part. You're creating your own equation based on some situation. That's not always going to be easy. So imagine the equations for predicting the weather, for example. Right? I don't know if you realize this, but when they make a prediction about the weather, it's based on at least 7 different models that have slightly different equations based on what you think is going to govern the weather the most. We're just freaking humans, but we're doing a much better job than we used to for that, believe it or not, especially somewhere like here. How long can you go? Normally with rain, like 70% chance of rain means it might mist a little bit normally for... Yeah. All right, so we're just going to kind of jump right into this. And just to let you know, what kind of sucks about teaching equations is just to get used to solving them, we have these equations that kind of come out of nowhere. And then students lose a little faith in the whole process. Equations in real life don't come from nowhere. They come from observations that we make. Right? We want to be able to predict what's going to happen based on what we've seen before. And we try to identify what are all the variables that might affect it happening again. So will a hurricane hit us? Well, let's go look at some historical data, look at what was happening when the hurricane did come this way, and try to make a prediction, and then sit back and hope. Right. You guys kind of with me? So, I mean, real equations will come from observations, will come from physical reality. In this class, we're just learning how equations work, so the equations might just come out of nowhere. Right? And so just kind of realize that. Just kind of go, all right, this one's just me getting used to equations, not this equation should mean something. No, not yet. So some of the basics of what's happening here. Let me give myself some scrap paper. If I say x is 2, right? If I just say that, and why am I allowed to say that? Because x can be whatever the shit I want it to be. Unless it's got to try to make an equation true, then it's got to be a certain value. So I'm kind of doing this backwards now. I'm saying, let me pick a value for x. Now on top of this, let me build an equation, right? So for example, and this is have you guys ever seen Raiders of the Lost Ark? Have you guys seen Raiders of the Lost Ark? Indiana Jones? If you have not, I know it's back like 30 some odd years ago, but still, they made really good movies in the 80s. That's when they made good movies, really. So the whole thing about taking the gold statue off and replacing it with a bag of sand, trying to equal that out. So with equations, it's kind of related to that. If I add or subtract a certain amount from one side, I better do the same to the other side to make the equation still true. So think about it like a balance. If I add 5 grams on this side, I better add 5 grams on that side, or else the damn thing ain't going to balance. If I double this side, I better double that side, so the balance remains the same, so they're still equal. Right? So the whole adage about whatever you do to one side, you need to do the other side, that's why. So here, if I take this and I add 7 to that side, I better do the same thing to the other side, so then x plus 7 is 9. Now if I ask you, what number do you add 7 to get 9, you should be able to tell me 2. And you might say, there, Jeff, I didn't need algebra for that shit. I'm like, well, yeah, that's not what algebra does. Algebra is when there's too much stuff happening for us to undo it all in our head. Right? That equation is really simple. You don't need algebra for it. I didn't have to write an x there. I could have just said, all right, students, what do you add 7 to get 9? 2. Okay, great. That's great. So that's not true algebra. What if I do this? What if I double both sides? So then I get, what can I do here that we talked about? Yeah. 2x plus 14 equals 18. So now it's getting a little bit stranger. Are you guys with me? Okay. I like it. And then I could just keep doing stuff and keep doing stuff. But the reason I like to show this example is because to solve an equation, I undo what somebody sat back and did. That's one way to think about it. Right? So if I give you this equation, if I said solve this equation, who knows what the first thing is that I would do to solve it algebraically?
Subtract 14.
Get x on one side.
Yeah, so eventually my goal is to get x by itself on one side. I can't quite do that yet. I like the idea of subtract 14, but realize why that really makes sense, because it's sort of like the thing I did here. 7 times 2 is 14. I kind of added 14, so I got to subtract 14 to work backwards. I'm trying to uncover what x must be. Undo what somebody did to the poor x. Poor little x dude. All right. So here, let me splash this up here. Well, actually, I can just do this right here. So tell me, how would you solve, let's do a nice easy one first. And then I'll unleash you guys on a few. How would you solve that? All right, beautiful. Let me just stop this real quick. You know, the goal is to get x equal a number, because then I know what the answer is, right? So what's in the wrong place? I like to think about it like this. What's in the wrong place? Got 11, because it's with my x. I don't want the numbers over there. The numbers should be on the other side. X is on one side, numbers on the other side. So I move that 11 out of the way. Get out of there. X is 20. Cool. And then you can check it. 20 minus 11, thank God, is 9. Check. Sweet. Okay. So, you know, a real life thing would be, how much fuel do I need to put into my rocket ship so that it actually gets up into space? You know, if I put too little, it's going to be great until it runs out and it goes, oh shit, I didn't put enough fuel. So how much fuel do I need to put in? So if I put too much, then it's too heavy. Who knows? There's some kind of sweet spot. Are you guys semi with me? So I can set up an equation, solve for x. That's the amount of fuel I want to put in there. There's a real life situation. I mean, that's what's really happening. So how would I solve this here? Exactly. So really, whatever operation is currently happening, you're going to do the opposite operation. I love it. So you hear that all the time. Do the opposite. Do the opposite. And why? Because you're trying to uncover the x. The x has been buried under all this shit. So you want to undo the stuff that somebody piled on top. So divide by 4. X is, that's crazy. And then if I check it, 4 times negative 7 is negative 28. Thank the gods. All right, sweet. So what about this? This is the one that kind of gets people a little bit, not that bad, but let me see what you guys think. Yeah, multiply by negative 12. I love it. Because what's currently being done in the x is being divided by negative 12. The opposite would be multiply by negative 12. And what do you get? X is 36. I love it. And then to check it, 36 divided by negative 12, sure enough, is negative 3. Check. I'm going to plug it back in. It makes the statement true. I love it. And then finally, what kind of mistake do you think somebody might do here? Yeah, like besides writing it down wrong. Sure, Jack. I know you're going to tell me what to do, but somebody might actually make a mistake. I'm sorry. What mistake do you think somebody could make? Yes, beautiful. That's the most common thing. I see this all the damn time. Somebody adds 6. And you can see where they're coming from, right? The 6 is negative. So the brain goes, okay, add 6, that'll cancel that out. But of course, that's not good because the operation is multiplication. So you always think what operation is happening. Let me do that opposite with that number, and it'll die. It'll be killed. So divide by negative 6. X is negative 2. Sweet. Sweet. All right, so let me do this. Let me shut up for a minute and let you guys try. If you have your book, why don't we jump in over this side? Yeah, I like it. Try out these. This is on page 2 of the blue book. Those 4 at the top there. Yeah, there are some decimals in there. Oh shit, there's fractions in there. Just to let you know, at least part of this first test, especially the first quiz, there's not going to be any calculators allowed. So just be extra sure that you can handle decimals and fractions. Don't rely on your calculator. Some of you guys have discovered on your calculator there might be fraction keys that do fraction work for you. Too bad you won't always have that with you. You don't know how to do fractions. All right, so what do I do on number 3 there? Beautiful. See, the x is over here. I want to get it by itself. It's subtracting 12. Let me add 12. And of course, what do you get then? 10. I love it.
What if I did x equals 10?
Beautiful. Same thing, right? It's like saying Jeff makes the same amount of money as Sally. No. Sally makes the same amount of money as Jeff. And it's the same. You guys With me?
Yeah.
It's actually called the reflexive property that you can turn it around. We actually gave it a property name. The reflexive property. Reflective, like reflecting into a mirror. It's crazy. Number 4, what's up with number 4?
Add 8 and 3.
Yeah, so first you can do, make that 11, right? And then add 4. M is 15. 11, I like my M there.
It is negative or
That's
the.
a neat M. I made like the second loop before I made the first loop, so it's neat. Second?
Number 3. It is negative then, yeah?
Definitely not. So, in general, I was going to say this earlier, so maybe I need to say this. To me, there's like all these crazy rules for adding, subtracting, side numbers. There's only 2 things you need to remember. If the 2 numbers, like that's negative 2 plus 10. So the 2 is negative, the 10 is positive. If the numbers are different signs, you subtract them and put the sign of the bigger one. I'm sorry, I forgot it was 12. So, negative 2 plus 12, right? So 12 minus 2 is 10. What's the bigger number?
Bigger number is negative 12.
No, the bigger number is positive 12, right? What is the actual work that we're doing? The very first thing, what do we do the very first thing? What's the very first thing? We added 12.
So actually I do it in another way. That's so it give me negative 10 because.
All right, so help me out. Well, how'd you do it? Did you,
Yeah, I think he added 2.
you added 2. I know what you did. Let me see.
Yeah, I did like this. It is negative 2. It is negative 2.
Oh, I see. Okay. You ready? You ready? And this isn't just for you. This is for everybody. You guys are your own worst enemies when it comes to solving equations. So, especially when the equations get kind of big, you try to do it in parts, which in general is kind of a good idea, but then you put them back in the wrong place. The most important thing in that equation is the equal sign. It's denoting what the sides are. If you lose it and then bring it back in later, you could very well be wrong. So, the equal sign is right here, right?
Yeah.
So, if I add 2, what do I get here? I get 0 equals x minus 10. There's your negative 10, but is the x in the right place? Is everything in the right place? No. So do you see how you lost the equal sign in your work?
I have lost it here as I did.
You did. What's the very next line? You don't have an equal sign anymore.
Yeah, I have it.
You have the bar, right?
Yeah, the part I have.
You have the bar, not the equal sign.
This is x. And this is
No. It's the very next line. Where's your equal sign? That's how that goes. So there's more than one way to do this problem. I'm telling you, the way you're doing it is not going to work because you brought the x to the other side. How did it get over there? So if I want that x to go to the other side, how do I do that? If I want the x to go to the other side, I have to subtract it, and then it would be negative.
Yeah.
Yes, good, I love it. So yeah, if you would have done that, if you would have put negative x. Okay, so far? So those cancel. And then add 2. There's your negative 10, but why are you not done? X is not by itself yet. Divide by negative 1, x is 10. Alright, so I desperately ask you to come see me. Because I need to help you with your formatting. Or else, I don't want the formatting, the way that you do a problem, to be the reason that you get a problem wrong. So you gotta be nice to yourself. My God, math is already, considered to be mean enough. Why do you want to be part of the meanness, right? You gotta be nice to yourself. The way you organize it is going to affect how you do the work. And if you lose where things are, that's going to really mess you up. So my big hint is to not break it up into parts. Rewrite everything right where it is each time. Because the equal sign is huge. If it ends up on the other side, it can't just float over there. You actually have to do the opposite to get it over there. So that's pretty much what happened to you. What about number 5? This one's not too bad, except it's got the decimal, but it's not too evil. Yeah, subtract 3.2. So you get P equals 6.3. Beautiful. And of course with decimals, when you add, subtract, you got to make sure the decimal place lines up. Do you know why? So help me out real quick. Let me just go off on a tangent here. If I had 6.1 minus 2.19, right? Or even the other way around. Let me make it like a 6.19 minus 2.1. I don't want to do this, right? And here's really why. What kind of things can you combine? What has to be true before you can combine two things? They have to be like terms. I love it.
Decimal.
The decimals have to be in the right place because of the fact it's actually a like terms idea. What does this 1 represent here? This 1. Tenths. And this 1 represents tenths. So if you line the decimals up, then all your like terms line up. It's a very small point, but if you never really thought about it, that's why we make you line the decimals up, so all the like terms line up. I like it. Okay. That's a nice little side note. And then number 6, it's a nice problem. It's a fraction problem, but who cares? Because bottoms are the same, because that's what makes it hard all the time, right? It's the freaking denominators. But this isn't too bad. What do? I don't have to do the reciprocal because the operation is addition. The reciprocal would be if I have to divide a fraction. Then I would multiply by the reciprocal. And when we get to it, I can explain why that's true. You know that rule, but do you know why it's true? Very often I find no, people don't. They don't blame you because nobody ever showed you. So here it's just number equals number plus t. So I don't care what the number is, I'm going to subtract the number that's with the t. It happens to be a fraction, so, oh well. So then I get 3 sevenths minus 5 sevenths is negative 2 sevenths equals t. I like it. Now let me just say this. If you had any trouble with those problems, you need to come see me. That's a skill that you should be coming into this class with. I'm not trying to make you feel extra bad if you have trouble with that. It just means you need to come and see me and I can get you back up to speed. All right? Or see a tutor at least. Try to come see me. Something. Cool. And then real quick, let's try just a couple of these. Yeah, here's where we get interesting stuff. On this next little section, do number 3, 4, and 6. So number 6, you got a little hint about how to do that just a minute ago, which is good. Hints are always nice. Here's where I'm going to show you why the rule is to multiply by the reciprocal. Don't ever take a rule as just, well, that's just the way that shit is. No. You should be like, well, why? Show me why. If the math teacher can explain to you, then they shouldn't be a math teacher, because that's what math teachers are supposed to do. So how do I do number 3? Beautiful. So right now it's negative 3 times b. I have to use division to kill that. I watched too much Game of Thrones, I think. Carry. Chop off parts. And then 14 divided by negative 3 is written a little better as negative 14 thirds. Now if I wanted you to, if I asked you to, and I might do this sometimes, leave your answer in mixed number format. How do I change that into a mixed number? Divide by 3 and then get the remainder, all that kind of crap, right? Let me show you a slightly different way. 14. It's a little bit bigger than a number that I wish was up there. What number do I wish was up there? 12. So what is negative 14? Isn't it negative 12 minus 2? Right? What's negative 12 divided by 3? Negative 4, and then you got an extra 2 thirds. Negative 4 and 2 thirds. Now, of course, you can get there without even writing it like that. 14 is 2 above 12. 3 goes into 12, 4, and you get that extra 2 left over. Left over the 3. Hey, that's another way to look at it. Or just long divide the thing and look at your remainder. Whatever way you have to make mixed numbers. Beautiful.
So it always has to be the number that's below the number that's up there?
Yes,
That's 14.
exactly.
Okay.
Because you're trying to think, it's a little bit beyond something, so you're always trying to take it back down.
So it would be wrong if we try to round it up to
15, yeah. It would be a little wrong. It would be, you could still make it work, but it'd be a lot more difficult.
Okay.
Yeah.
So like on quizzes and tests, would you accept either answer or do you prefer?
Oh, I would accept either answer if I don't say to leave your answer in a certain form. Because both forms are valid. It's just normally mixed numbers are a little bit better, especially in a word problem. If you're like, how far away do you live from school? And you say 14 thirds miles, I'm like, who the hell are you? Right, before 2 thirds, like, oh, just under 5 miles. That's a human response. It makes me feel a little better about it. You're not some alien or something. Right? Okay. But if I don't say, either way, it's fine. So what about, oh, sorry. Negative 14 is negative 12 minus 2. Right? Just rewriting what 14 is. 3 goes into 12. Negative 4 times 3 goes into 2. I don't know, so it's left over. I love it. Now, real quick. Mixed number notation is one of the most evil things, believe it or not. Because what does 4 and 2 thirds mean? 4 and 2 thirds. It's not 4 times 2 thirds, because that would be 8 thirds, which is way less than 4, which makes no freaking sense. 4 and 2 thirds should be more than freaking 4. Are you with me? So it's unfortunate that we chose that notation, but we weren't around back when they did, so oh well. Yes?
Don't you but to get back into the where the top is more than the denominator, don't you times by 3 and then add 2?
Are you ready? So here's the thing I was about to get into. You ready?
Yeah.
So this is negative 4 and 2 thirds, and you're thinking about how to get back to where it was, and the mistake students always make is they go 3 times negative 4 is negative 12 plus 2 is negative 10, which is wrong, and we know it's wrong. Here's why. There. 3 times 4 is 12, plus 2 is 14, put the negative back on.
Okay.
Because you'd have to, and it's all related to the fact that if there's a negative, it would have to distribute to both parts. That's the mistake we make. So it's not really adding to then, it's subtracting to. And why do that shit to you? Just take the negative out of the way for a second, put it back on at the end. I like it. Whenever I explain something, it can feel like some people now understand it, and some people that thought they understood it are more confused. I'm sorry. I always have, oh shit, see? Somebody's like, you just did that to me. I'm never trying to do that to anyone, so. So what about, oh sorry, I skipped number 4. What about number 4 real quick? 4 should be easy. Divide by 6. X is negative 4. Sweet. What about number 6?
times by 8.
Yeah, and why does it make sense? What would you do in number 5, for example? I know I didn't assign it, but you would just do what?
Times 5 times.
Multiply by 5. Like, so here, if I ignore the 3 up there for a second, I know I would multiply by 8. But then I'd have 3y left, and then I'd have to divide by 3. So when I multiply by the reciprocal, it's just doing both at once. So I'm multiplying by 8 to kill the division of 8. I'm dividing by 3 to kill the multiplication by 3. So the 8's die, the 3's die, y is left by itself. And what do I get on the other side? What's, if you want to, 3 over 1, right? What's really nice? 3's cancel, so you get y equals 8. You don't. You could actually do, so here, real quick. So if I had this problem, what?
I can't see it.
You want to be able to see it? Man, you guys are so needy. All right. So if you see that you need to multiply by 8, and you know it's going to make your problem look better because you're going to kill the fraction, right? Then just do it. So if you multiply by 8, I get 3y equals 24, and I know I'm not done. Divide by 3. So you see, multiplying by the reciprocal is really just doing both of those at once. Now, since we're talking about multiplying by the reciprocal, I want to ask you a more basic question and see if you understand why this is true. If I had 2/5 divided by, what you got, Jeff? I don't know, dude. 4 25ths. If I have 2/5 divided by 4 25ths, you guys, most of you should know the process. What do?
Change the second. You flip the second and multiply.
Good. Multiply by the reciprocal. Now that's a rule that you know. Do you know why you do that? Do you know why that makes it work?
Oh, no, I was right now.
I was like, oh.
Because then that allows you to simplify your fractions.
But see, it's not a question about what it allows you to do, but why am I allowed to do that? Why is that the procedure that will get the right answer for this question? And this isn't an equation, is it? So it's not like I got like two sides to balance out. Now, please, guys, I appreciate the replies. It's awesome. Because normally I don't get anybody even try to give me an answer. It's awesome. And I don't blame you because you've never been shown. You just were just like, this is what you do. Okay.
No.
Now, I'm going to show you why it's true. I do not ever want you to do what I'm about to do to solve a problem. I am showing you why multiplying the reciprocal works. Yes?
Is it something about like complex fractions or something like that?
Yeah, yeah, I love it. Sweet. Yes?
Because you can divide the opposite, like 2 can go into the denominator.
And it's not, see, the answer can't be dependent on it makes it easier to do next. Right?
Yeah.
It's got to be a valid reason that you always do it. All right, here it is. Here it is. So I love that. That's awesome. So watch. Never, ever do what I'm about to do. So you're like, what the hell? I didn't just say never ever do what I ever do. I just said never ever do what I'm about to do. I'm going to show you the reason why something works. Dear God, just use the process that we know works then. Don't do all this craziness. All right? So what's another way to write something divided by something? We'll put one thing on top and the other thing on the bottom. So that was my man right there with the complex fractions. That is certainly something I would call... No, I love it. I love it. And I always get students like, what kind of teacher you have? You took that problem and made it look horrible. So remember, what did I say? I said it's going to look gross, never do what I'm about to do. But this is investigating how to do the problem. Now watch. What would be the best number in the frickin' world to have on the bottom of something? Come on. What's the best number to have on the bottom of something? 1.
Oh, yeah.
You guys agree? Glad nobody said 0. You guys with me? If I'm going to have a number on the bottom of something, make it a 1, please. I got a whole number. Oh, shit. Right? So, how do I make the bottom become 1? Times 25 divided by 4. And if I do that to the bottom, I better do the same thing to the top. Where am I at? Holy shit, Jeff. So this equals this, which equals that. And what's the bottom? So that equals that. So really that process of multiplying by the reciprocal is a shortcut. But you guys never get to see the long cut. And I know some of you guys are like, I could live my whole life without seeing that weird shit. But you're a little better off now because now you're going to buy into that process more because it's not just something we said to remember, it's something that just freaking makes sense. It's just the way you're going to do it. You guys understand? And then, of course, what would happen here? I know.
I know you're showing the steps. But
I know. Some of you guys are like, I prefer a teacher just said, just flip it. Oh, good. Just tell me what to do. And I'm really sorry that you prefer that kind of teacher because I ain't the kind of teacher I am. I'm not just a tricks person. I'm a freaking teacher. Right? And my job is to explain why things work, not just say, do this because it works. Right? It's not always the easiest job in the world. All right. And then what can I do here real quick just to kill this problem? Cross, divide.
yeah, you have to divide.
1, 2, so you get 5 halves. Is that cool? Okay. Is that cool? Okay. All right. Moving on. So help me out, just to get us ready for this next section. Now we're going to do some more advanced equations. It's not even going to be that difficult yet. I'm on my extra notes page, by the way. If you want that page, you've got a book. It's actually sort of two things you could do here, but what's the standard thing that we look for in equations? If you've done any equations, you should be used to what to look for first. What do you almost always do first? Distribute, if there's anything to distribute. Why do we do that? So that all the parts are then free. The one really common mistake I see on this, in fact, everybody do me a favor, just hold your pencil up. Don't write this. Don't write. Hold your pencil up. Don't write this. I see this. Done, Jeff. Next. So what was, and everybody else is getting fractions, and this guy's like, you guys suck. I got a nice number. What did this person do wrong? Is there a 1 up there? This is an interesting question. There is no 1. There's 3 times x plus, there's a 3x, and there's a 3. There ain't no 1. You can't break into that problem and get the 1 to escape. That's a neat, actually it's kind of a weird-ass shut. Number prison break or something. Let's start over then. Now you can put your pencils back down. You can use them. So the correct way to do this... Yeah, I love it. Exactly.
Sorry.
But I'm doing what's going to work more generally. Yeah. 3x plus 3. 7. Subtract 3. I love it. So here... So now we're at a stage where I have an x that's being multiplied, and also it's having something added to it. Right? So it's we were just focusing on what if I add or subtract, or what if I multiply divide. So this has got both things happening. In general, what you do after you've distributed and got your like terms together, you say, where are my x terms? Why are they not by themselves? So my 3x is my x term, right? Why is 3x not by itself? Yeah, stupid 3. Right? I don't want to divide by 3 now because then I get fractions way too early. If I'm going to get fractions, when do I want to get them? When I'm done. And I ain't got nothing to do with it. Now listen, I know math. But even me, I'm not going to bring fractions into play if I don't have to. Because I'm a human. It's easier to make mistakes when they're fractions or negatives and all this kind of business, right? Okay. So subtract 3, and you get 3x equals 4. And then divide by 3. So I do get a fraction, and I don't care, because I'm done. Now again, if I ask you to make a mixed number, 4/3 is an easy one, hopefully. 1 1/3, 3 4 ones with 1 left over. 1 1/3. I love the way we say it. 1 left over the 3. Hey, that's another way to think of it. All right. Now, real quick, I know that some of you guys are really good at solving really, really freaky equations. Anytime in this class when I'm doing something that makes complete sense to you and you're like, this, oh crap, what the hell? Well, number one is, I'm going to hit the point where it doesn't make any damn sense to you, so just hang on. Enjoy it while it happens. Number two, do not talk when I'm doing something you know, and just make it so that people can't hear what I'm saying. So in the back, I'm not always able to hear if people are talking. You got to let me know if somebody's talking, you can't hear what I'm saying. Let me know, and then I'll try to shut that down. So if you need to talk, sit near a door and get your ass out the room, and then you can talk as much as you want to. I don't care. All right. So let's get into this slightly more advanced stuff. Only slightly more. Let's see. This is page 5. Page 5, number 3. Now, what's up with that problem number 3? What's up with it?
You have two.
Yeah, I got 2 B's. I got 2 B terms, right? Is there any like terms on each side? No.
Oh, no.
On a single side. Are there? So normally what I do for an equation in general is I distribute, get my like terms together, and then I get all my variables on one side, all the numbers on the other side, right? I love it. So somebody's like done a lot of work already for this problem. It's one way to look at this. They distributed, they got the like terms together. All I got to do is pick a side to move my B's to. And normally I'm going to pick the side that doesn't make a negative come in. Because again, that's another place where we can make a really easy mistake. So I don't even let it happen in the first place if I can. So which way should I take my B's? What should I do? Yeah, if I subtract 2B, the answer is going to remain positive. Do you have to do that? I'm not saying you have to do that. If you're like, negatives don't concern me. All right, cool. Subtract 2B. And here you get 4 equals. You guys stop playing on 5B minus 6. And now you see what I mean when I say what's in the wrong place. That's a really good way to kind of look at the problem later. What's in the wrong place? Get it out of there. The 6 is in the wrong place. Add 6. Let me take this up here. So I get 10 equals 5B. I love it because these go away. And that's awesome. Yeah, divide by 5, divide by 5. 2 equals B. By the way, this brings up another common mistake I see. Is everybody cool with this so far?
Yes.
Be really careful. I haven't done this since the very first few that we did today. But if the instructions in the homework or on a quiz or something say, check your work, what would I do with this? Plug it back into the very beginning. Don't pick somewhere after that. That looks better. Because you might have made a mistake after that. Okay. Real quick, here's a very, very, very common mistake. I can almost not blame somebody for this. 8B equals 2, B equals 4. That is not right, by the way. What did this person do wrong? They didn't slow down. The brain said, 8 and 2, 4, kick-ass, done, next, yay. What are they supposed to do to both sides? Divide by 8. So that's wrong, got it. So if I have 8 equals 2, divide by 8, B is 1/4. Not 4, right? And I love it when somebody says, well, come on, it's like the same answer. All right, if you owe me $4 million versus $250,000, neither one is good, but which one would you rather be in? $250,000 instead of owing me 4. So come back at me again, is it 4 equal to 1/4? No, right? Same thing with like, the answer is supposed to be 7 and you got -7. If you made $7,000 versus lost $7,000, I think that's kind of a big deal, right? Quiet. Okay. What about number 4 here? What's this one all about? Beautiful. So do it. Do number 4. Yeah. Distributing. Distribution. It's a word that makes you sound drunk. Not me, it's distribution. That clock is right, correct? Is that clock right? Okay. No. They must really, really love their clocks. Now, the better you get with equations, there's actually something you could do with this equation that I could really nice. I'm going to pretend like I don't see it. And some of you guys are like, I don't have to pretend. I don't know what this shit you're doing. So the way to do this by the book would be to bring the 3 through, right? And what do you get?
18 minus 6x equals 18 minus 12x.
All right. I like this problem. This is the problem where people really freak out and give me some nifty answers. And you guys are like, I got one for you. What did you guys do next? Add 12x. I love it. That's actually a really smart idea. That's right. I'm smart. Okay, how's that? Some of you guys might have subtracted 18 and then you weren't sure what to do. But all you do is you get your x's together the same way you got your numbers together. So here, I'm going to subtract 18, right? Now here's where I get answers like 6x is the answer, Jeff. No, 6x equals 0. 0 is a number. Doesn't mean blank space, right? Careful. Now here's where, now watch. Stay with me now. If it was 6x equals 18, what would you do? Divide by 6. If it was 6x equals negative 24, divide by 6. If it was 6x equals 5, all right, so any number I put here, you're going to, because what tells you what to do is why the x is not by itself. Don't look over here and go, 0? What? No, I don't give a shit what's over there. I care what's here. So if you divide by 6, now it should not be that big of a deal. If I have nothing, and there are 6 of us, how much do each of us get? Nothing. It's not undefined. Right? That situation is almost too well defined. Nobody gets nothing. And you get negative 6. You would just get this, right? Right? So what you would get, alright, you would get, what would you get? You would get 18 equals 18 minus 6.
I think it's the same answer, but would you mark it wrong if I